All right, so we're going to find all the features, and I added two, so add these two to your notes. We're also going to find where it's increasing and decreasing. All right, so the first thing we're going to do is find the x-intercepts. That was the first thing we learned about in terms of finding features of our graphs. And the x-intercepts is where the graph crosses the x-axis. So we have two x-intercepts, one at -2, 0, and one at 0, 0. So let's go ahead and write that. And the x-intercept happens to also be a y-intercept, right? Because it also not only does it cross the x-axis at 0, 0, it crosses the y-axis because that's the origin. The domain, so this is understood. It's going to keep on going, right? It goes right off the graph. All right, so it's going to keep getting wider. So the domain is -infinity to infinity, or in set notation, that would be, let's see, I can squeeze it in. All right, let's try. X such that x is a real number. There we go, just got it in. And then let's do that. All right, so we just got it in. The range, all right, so here's our lowest value. All right, and as we look across, the lowest value is at -1. All right, so here's our y-axis. So our graph goes from -1, but it's got arrows. It's going to keep on going. So the range is -infinity, excuse me, not -infinity, it's pointing upwards. -1, and it does go through -1, so let's use a bracket. And then to infinity. All right, so that's our range. Because our low value is at -1, it's got arrows, it's going to keep getting larger. In set notation, that would be y such that y is greater than or equal to -1. And there's our range. We have no relative maximums, but we have a relative minimum right there at -1, -1. And that's where we change from, first we start off and we are decreasing. And then at -1, we start to increase. So the graph is decreasing. Oh, I have increasing first. Increasing from, sorry. There we go. Sorry, my eraser is really close to the camera button, and then the smart camera comes up. So, but now it's gone. I think it appeared on your screen. I'm not 100% sure. So if you saw a black screen for a moment, it's just because the camera button came up. All right, so let's fill in increasing. So we are increasing from -1 to infinity, and we are decreasing from -infinity to -1. At -1, we switch. All right, let's try the next one. We found everything, all the features. So these are all the features we learned about. X-intercepts, y-intercepts, domain, range, extreme values, and increasing, decreasing. Right? All summed up on one graph. Let's do one more. All right, so our x-intercepts, we have 3 of them shown there. Each of the boxes is worth 2. So this would be -4, 0, and -1, 0, and 2, 0. So those are the x-intercepts. We have one y-intercept, and of course that's all we can have for a function, and it's right here. All right, so that's the point 0, -8. Oops. I got too used to writing infinity symbols. There we go. And now our domain, we have arrows on both ends. So interestingly, on the x, we have arrows, so it's going to keep going out. And they're facing opposite directions, so it's going to keep going down, and it's going to keep going up. So our domain is going to be all real numbers. So -infinity to infinity, or x such that x is a real number. And the range, likewise, is going to be -infinity to infinity, or y such that y is a real number. And actually, this is a cubic function, something cubed, x cubed. And if we have a cubic function, it is going to have a domain of all real numbers and a range of all real numbers, because we can take the cube, we can cube any number, and we can take the cube root of any number. So any number, any y value can be reached by cubing some number. All right, our relative extrema, we have two. We have one right here at, I guess that's about maybe 1. Let's see, each box is 2. That's like, it's not quite 3, but let's call it 3. So, or -3. -3, and this would be 10. Oh, it's a smidge more than 10. Let's call it 10.5. And then we have another, so that's that one right there. We have another one right here. And, that's just so close to, let's call it 1/2. Because a full box would be 2. I guess that looks like about 1/4 of the way. And then going down, it's just a smidge more than 10. Let's call it, I guess we'll call it -10.5. All right, sometimes you have to approximate. If your approximation is reasonable, all right, it's fine. That's reasonable from what we can see on the graph. All right, so we have a relative maximum at -3, 10.5, and a relative minimum at 1/2 or 0.5 if you prefer, -10.5. Of course, I could have wrote that -10.5 as -11 halves. Or excuse me, -21 halves. All right, so now we want our increasing and decreasing. All right, so first, our function increases till it gets to there. And then it turns around and decreases. This would be the fun part of the roller coaster, at least to me. And then it turns around and it increases. So our graph is increasing from, let's see, what color did I'm going to write in, I guess I'll write in, I wrote in every color, I guess green. We're going to increase from -infinity to -3, and then again from 1/2 to infinity. And then we're just decreasing in between there. So we're decreasing from -3 to -1, to +1/2. And that's where we are decreasing. And there we go. All right. Well, that's it for features of functions. In the next Nearpod, we're going to be looking at translating functions. So thanks for watching, and bye for now.